In this problem, we're given the excess Gibbs free energy as a function of mole fractions of the two components in a binary mixture, and we're given the constants A and B in this equation. R, of course, gas constant, T is absolute temperature. And the question is, if this expression is obtained from data with some limited range of concentration, does this liquid mixture have phase separation? And then if it does, can we determine the range of compositions where we have phase separations? And so what we want to look at is the change in the Gibbs free energy for the mixture, and that's going to be a function, of course, of the mole fraction. So the change in Gibbs free energy divided by RT to make it dimensionless is the ideal solution change in Gibbs free energy plus the excess Gibbs free energy. And the ideal solution, the change in Gibbs free energy is this, so ideal gas or ideal solution. And then we're adding on to that the excess Gibbs free energy. So what we're going to do is substitute in this expression for excess Gibbs free energy, and then easiest things will be to plot what then delta G over RT looks like. So let me pause and substitute this in. This is what we're going to plot, and we're going to plot delta G over RT versus x1. So let's look at what that plot looks like. As you can see, it has minimums. Remember, the idea of mixtures is we're going to go to the lowest Gibbs free energy. So we can see from this plot that we can obtain lower Gibbs free energies over a fairly broad region. Let me draw just a straight line, which is a tangent. So between about 0.12, if I look in a spreadsheet, and 0.84, that's where the local minimums are. Over this entire region here, instead of having this Gibbs free energy, we're going to have this Gibbs free energy, which means we're going to have two phases. We're going to have this phase mixed with this phase, and the amount of each phase we could determine from mass balances or from the lever rule. So this system for this excess Gibbs free energy indeed has phase separation and over a fairly wide range of compositions.